Before we begin any new topic this semester, we will need to review Lewis diagrams. Lewis diagrams are going to be very important in terms of getting it proper so that hybridization, polarity, geometry, number of pi and sigma bonds all come properly from a correct Lewis diagram. So we will start off with a review of Lewis diagrams, and we'll do ammonia right now. And ammonia is NH3, as hopefully you recall. One of the first things we need to recall is the number of valence electrons that are donated by all the atoms that are in the compound. In this situation, we have ammonia. It has nitrogen, which brings 5 electrons to the bonding procedure, and hydrogen each brings 1 electron for a total of 3, and the two of them combined bring a total of 8 electrons. Then we need to determine the central atom. The central atom is typically the one that's written first. There are other ways that you can determine which is a central atom if it's not too clear. The other way is that the most metallic, the one that's furthest to the left on the periodic table, as hopefully you recall that as you go to the left, compounds are more metallic, with the most metallic being down at cesium, or the least of the electronegative. Once you've determined the central atom, then you put around the others. For here, hydrogen. Each hydrogen is attached to the nitrogen, as it can only form 1 bond. Hydrogen will never be in the center, so that when you have ammonia, we have nitrogen in the center and hydrogen as the 3 terminal atoms, and that consumes 6 electrons. There are still 2 electrons left, and the next is to fulfill the octet rule, and in this case nitrogen is the only atom that can fulfill the octet. Therefore, the final 2 electrons go onto the ammonia, as you will see, and that will give us the final Lewis diagram.